Hi, my name is Nicholas Espinal. This is my third question for my Chapter 25 quiz, and this is what it asks. A cylindrical wire has a resistance R and resistivity ρ. If its length and diameter are both cut in half, A, what will be its resistance, and B, what will be its resistivity? So first we have to ask ourselves, how are resistance R and resistivity ρ related? Well, we're given this equation, resistance R is equal to the resistivity rho L over A, where L is the length of the resistor, A is the area of its cross-section, and rho is the material's resistivity, which is a property of the material. So if we are talking about the area of its cross-section, we're going to be looking at this here. This is the cross-section of the wire or any type of resistor. And this is the cross section, and this is the area that the equation is talking about. The area of this cross section of a cylinder is going to be pi diameter squared over 4, and where d is the diameter. So since we have this equation, resistance is equal to the resistivity times L over A, where A is the cross-sectional area, we can put this equation into the resistance formula, and we're going to get rho times L is all over pi times the diameter squared over 4, or in other words, that we're going to get the initial resistance with what we're given as 4 times rho times L all over pi diameter squared, and this is going to be our initial resistance. So if the length and diameter are cut in half, we're going to have the length is equal to L over 2, and the diameter is equal to the diameter over 2. So if we still use this formula here to find the resistance, and we just input our values for the length and the diameter, our new values for the length and diameter, we're going to get this equation. This is not so nice to look at, so we're going to simplify it. When we simplify this, we're just going to get 8 times rho times the length all over pi times the diameter squared. Now, if we compare what we just got, our new resistance, to the original resistance, which was 4 times rho times L over pi diameter squared, we're going to notice that the new resistance is just 2 times the initial resistance. If we get the initial resistance 4 times rho times the length all over pi diameter squared, and we multiply that by 2, we're going to get the new resistance that's what we just got, 8 times rho times L over pi diameter squared. So we can safely say that the new resistance is just twice the original resistance. Now, how does cutting the diameter in half and the length in half affect the resistivity? Well, the thing is that the resistivity is a property of the material, and that is not going to depend on the dimensions, but it's going to depend on the material itself. So if we are only changing the dimensions of the material, the resistivity is just going to remain the same. It's not going to be affected. So when we answer these questions, we derive that the resistance, the new resistance, is equal to twice the original resistance, and the rho, the resistivity, doesn't change at all. It stays the same. We find our answers here, and we just answer the question. And we use the definition of resistance and our understanding of what resistivity is and how it's a property of materials to answer this question. Thank you.